Okay, this is the third lecture in the course on LSI systems design, and as opposed to yesterday, there's a lot of material to cover today, so I'm going to step right out here and move on. First, I want to talk about projects. I hope you're all planning projects. That was a prerequisite for the course, remember? That's what got you in here. That's what will get you out of it. The projects are due April 20th. That doesn't mean the stick diagrams through April 20th, or sort of system conception done April 20th. That means finished layouts done and checked and verified and signed with approval. This will work for sure, done by April 20th. And second half of that is nothing's too small. Just do something. Do something. Even if it's counter, your favorite version of today's homework assignment, your favorite version of a flip-flop perhaps would be a suitable project. But let's get everybody just really thinking in terms of putting something on silicon and let your ideas grow from there. If you don't have any specific ideas, talk to the guy next to you. He's probably got 5 ideas, and he wants you to do one of them. So maybe you can work together and get something that way. If your favorite project is too big, you want to build this multi-processing system, maybe you just want to build one of the processors for your first chip. And if that's too big, perhaps one of the registers in one of the processors. One of the storage elements in one of the registers. And if you still want to build that multi-processor system, find somebody who wants to build the rest of the register or the rest of the processor for you and start working with him. So the idea is, let's get started. Let's start thinking seriously, and we'll do it April 20th if you'll do it April 20th. Okay, next. Okay, the homework. The first problem, the basic intention was to make you think about various types of solutions, and rather than necessarily getting all the detailed ways of doing each one, the idea is that people used to designing with TTL, for example, when you say counter, they think a bunch of 74 161s, and if you want 4 of them, 4 bits, you get 1 package. And the point is that you can sort of emulate that function of a counter in LSI. That is by no means necessarily the best way to do it. I want you to think in terms of what is the basic function that you want to perform. Now, you want to perform a counting function doesn't necessarily mean you want an explicit counter as we normally think about it. For example, I suggested the PLA as a particular alternative, and several people did an implementation involving a PLA. You also might do something just using a register with an incrementer, a parallel incrementer, or an adder on the output, which is fed back to the input of the register. And every time you clock the register, it increments the value in it by 1 and stores the new value back. That function and may in fact be a lot smaller. I don't know whether it is, but it may be a lot smaller than building it this way. This is one way I know of doing sort of the typical counter thing, where you use the pass transistors as a carry path to propagate forward the state of each of the previous flip-flops. And if a 1 propagates, for instance, to this toggle input, on the next clock cycle, there should be clocks going to each one of these. On the next clock cycle, you just flip the flip-flop, or toggle it. And if both of these are 1s, then you toggle this one and toggle these back to 0 and so forth. So that's one way of. There's another interesting solution.